Hey everyone, welcome back to my channel. Today we're going to work on data pre-processing using Python, and I'm going to use this website, and I will use this dataset itself. This has missing data here, it has categorical data, and we're going to use label encoder for this. So let's get started. Just type Google Colab and click on this. Okay, click on new notebook. Make sure it's connected using your email address. Mine is already. Okay, now I'm going to import libraries. Okay, when you are working with dataset, you always need pandas, and when you're working with numerical data, you need numpy. And I'm typing this as PD because we're going to use PD instead of pandas just for convenience. Okay, so this green check mark means it was run successfully. And now let's import our dataset. Our dataset is not here at the moment. We will need to bring it over here, but let's just try to see the error message. So for the dataset, we use PD or pandas dot and this is our dataset, which is not here at the moment. So file not found error, so just click on this upload, and this is what we're looking for. So basically it's telling me that if you log out, this data will disappear. Sure. Okay, now that we have dataset, we are able to read this. Let's add a code cell and let's separate x and y. X is going to be independent variable and y is going to be the dependent variable. Basically, country, age, and salary are the independent variable because purchase of car is very much dependent on the country, age, and salary of a person. So this purchase of car, this purchased column is dependent variable. So we're going to separate independent and dependent variable first. So let's do that real quick. So capital X is independent always. So dataset dot index location, and we're going to select everything from the rows, but for the column part, so basically rows means from France to France, 44 to 37, basically everything from the rows. So for the column part, we're just going to select this 0 index, first index, and the second index. Well, to do that, in Python, from 0, so it be 0 to 0, 1, 2, right? So if you do 2, this upper bound is always cancelled and you're only going to get until age. So it has to be 3, right? But we're trying to make this more generic. So I'm going to use -1. It works exactly the same, dot values. Okay. Now let's print X. Okay, so we have these 3 columns here with us. And now let's get the value of dependent y. So small y is equals index location, and it's everything from the row and -1 from the column as for the range, because in Python if you do -1, it's going to select the last column for you. Okay, and dot values always. Let's try to run this. Okay, so we're getting the data. We have separated dependent and independent variable here. Now let's work on our missing data part. So this NaN, this is not a number, so we need to figure out what we are going to do with this missing value. So let's add a code cell here, and we're going to use this library sklearn, and we're going to use our impute model from sklearn. So from sklearn impute, okay, import SimpleImputer. Okay, so basically this is going to help me to work with missing data. Now these are numerical values. We're going to replace this with mean. Okay, now let's say si for SimpleImputer, and let's create a class. Now, as you can see with the intelligence, we have missing values and strategy that we can use in the parameters. Here, you can read more details. Okay. Okay, missing values. Missing values is going to be np.nan. np is numpy. We're going to work with, when it comes to working with numbers, we're using numpy np dot, not a number, and strategy equals, inside comma, we're going to type mean. Okay, and well, we have something called fit and transform method, so let's use that first. si.fit, going to fit x, and I'm going to give the range everything from the row, and for the column part I'm just going to give this is the first index, this is the second, and this is the third. So I just need second and third's value to be worked on, because we cannot work on these string. So 0, 1, 2, and 3. So okay, now fit is going to use formula of mean over here and over here. It's just going to use formula and get the mean, that's all. Now when we use transform, it's going to well, transform these values. So si dot it's going to be, the range is going to be exactly same like the above, from 1 to 3. Sure. Now here, let's see. Okay, so once it gets transformed, you need to store it somewhere. So I'm going to store it in X, and inside X also we need to specify where exactly. So basically the same, 1, 2, 3. Okay, now let's print X and see. Okay, sure. So basically this was converted to the mean, these two values, which were not a number initially, so what has been replaced with mean, which is good. Okay, now that this is taken care of, we're going to work on encoding these categorical data. We cannot use 0 and 1 for these, because if we use 0 for France, 1 for Spain, and 2 for Germany, it's going to assume that 3 is greater than 2, or Germany is greater than Spain. That we were feeding wrong information to the ML process, machine learning. So I'm going to use OneHotEncoder to encode these into binary. Well, actually, let's see how that works. So we have a library from sklearn.compose. Okay, this is a model that you can use. Import. Should be something ColumnTransformer. Okay, ColumnTransformer. And we're also going to use OneHotEncoder, so let's import that also. .preprocessing. Let's see the intelligence. Okay. All right. So using this column transfer, we are eligible to use OneHotEncoder. This is how it works. Okay. Let's see that in action. So for ColumnTransformer, let's type CT and create a class. Okay. Now, as you can see, we're going to use 2 of the parameters as suggested. So we're going to use transformers and a remainder. So, okay, this one. And let's also add remainder. Okay. So for transformer, we're going to have a tuple. It has 3 things in there. So okay, so we're going to use encoder here, and the function, it's going to be OneHotEncoder. It's a function, and then we're going to specify the index in which this OneHotEncoder is going to work on. So it's 0 for this case. This country is in 0 index location, so 0. Okay, now remainder, we're going to use passthrough. Sorry. Okay, this passthrough basically means that just work on this index, 0th index, and don't touch these other 2 indexes, other 2 columns. That's all. This is very important. I'll tell you just in a second. Okay, so now ColumnTransform is done. Let's use si.transform to transform whatever we encoded into X. So ct dot fit and transform X, and let's store the value whatever was fitted and transformed into X, and let's also print X. Okay, so basically, as you can see, it was able to convert France to 100, Spain to 001, and Germany to 010. Okay, so basically it added 3 columns. So that's how categorical data is encoded. And we used passthrough here. That's why we were able to use X inside si.transform. If we hadn't used passthrough, it would have converted all these into binary. So using this passthrough, it didn't touch any of the other columns apart from 0 index. That's all. All right, now let's add a here. Okay, so here. So this is taken care of. NaN is also taken care of. Now we need to convert these yes and no into zeros and ones. We're going to use label encoder for that part. It's very easy. Now let's import first from dot label encoder. Okay, now let's say LE for label encoder. Label encoder, and it doesn't have anything inside as part of parameter, so let's just leave it like that. Now LE dot fit and transform y, and let's store the value whatever was transformed inside y, and let's print y, and let's see. Okay, so basically it was able to convert 0 1 0 0 1 1 for yes and no. That's all. Okay, now that we have done this, now we're going to split this into training and testing. So we're going to use from sklearn dot this one import train test train. Okay, this is what we're looking for. Okay, what I'm trying to do is I'm going to add 80% of the data into the training model and 20% into the testing model. I'm just going to I'm trying to split it. That's all. So, well, you can actually open your ChatGPT and learn more about train, test, and split here. Okay. All right, now, so we're going to do x underscore train, comma, x test y equals this is what we need, and inside this we have x, y, and the other thing we have is going to be size, test size. Let's see. So basically test size is going to be always 20%, most of the time actually. So 0.2. We're going to only use test with 20% of the data, and the 80% will go towards the training purpose. And the last is going to be random state, this one. Equals 1. Basically it's telling us to randomly separate the data into training and testing sets. Okay, now that we have this done, let's run. Okay, now I'm going to print okay 4 5 6 7 8. So we have 8 rows, which is correct because we have our total number of rows were 10. So 20% was secured for the test set and 80% for the training set. And let's copy this Instead of train, I'm going to type test. Okay, so these are the test sets. Now let's see for Y. Okay, so for these purchased part, yes and no, this part, this is the training set and this is the testing set. Okay, so this is done. Splitting the data into training and test model is also completed. Now we're going to use feature scaling. So we always use feature scaling at last because we don't want any data leakage. To use feature scaling, we use standard scaler, and we are always going to use standard feature scaling rather than normalization, because not all the times the data is in normal format. So using standard, it's always a safe side. So let's import that. PORT. Standard scaler, it's not oh sorry about that. From now it should work. Okay, right, now we have this standard scaler. We're going to scale the training and test set. So we're going to do SS for standard scaler. So inside standard scaler, let's see what it has. Looks like it doesn't have anything as a parameter, so ss dot fit and transform. We're going to pass x training set, and we're going to pass the range here, everything from the row, and we are passing this range because, let's go up and see, we are not going to work on these binary values because it's already scaled. Okay. Scaling means, so let's see, we have 38 here and we have 35 here, 48 here, but we have 52,000 over here. So we want to scale it such that all the data are in between -3 and +3, or -1 and +1. We're using the standard scalar process, so it's between -3 and +3, I assume. So this is 0, 1, 2. We're just going to start with the third in the location. So 3 and 4. So we're going to 3, 4, and 5 is going to be the right range. So from 3 to 5. and let's copy this. Okay, and it's going to store it inside this xtrain. Now the training set has been scaled. We're going to work on test set now. X test set, and test set also the same thing, everything from the row and from 3 to 5, right? ss dot. So let me tell you something here. Using this fit, we have already applied scaling formula to for the standard scaling. Once the scalar has already been fit in the data, if we use it again, it's not going to work efficiently. So we are not going to work anything related to the formula. We're just going to transform, and we're going to transform the same thing. Let's copy this and let's paste it. Okay. Now let's see if we can run this or not. Okay, there is a problem here. Okay, let's see. Okay. Copy this. I think the spelling was wrong. Okay, yeah, the spelling was wrong. So right now I'm going to print training and test set. Okay, let's copy this and okay, basically it scaled the values. So instead of so let's see about this value. So it was 52,000. So it scaled from between -3 and +3. Everything's well scaled. These are not touched because it's already scaled, and we also don't want to scale anything from this dependent variable. Let's see where these, because it's already scaled. It's just zeros and ones. It's pretty normal, so we don't want to do that. So this is all about data pre-processing. If you have any questions, please feel free to comment below. Thank you.